Okay, so let's get it started. It's great to see so many of you here present in person. So we are going to start our course titled Cartographic Visualization in GIS. This is the first time we are teaching this course, so hopefully it will be a course in which you will learn a lot of good things, useful things about cartography and map making. At the same time, those of us involved in organizing the course will probably learn a lot from you, and we will use them to develop the course for the coming years. But yeah, so I already sent an introduction email last week. My name is Pavyar, and I will be the main responsible teacher in this course. Other people will be helping me during this course. Tato is sitting here, but yeah, so I will still go through the list of other people who will be helping us during this course. But I will start today's lecture with a bit of introduction to the course. So I will show you around the website. It might be a bit try to make it as clear as possible, but it might be a little bit confusing for you. So I will just walk you through what we have here and the structure of the course. And hopefully it will make more sense after this. Yeah, so this is a course in cartography, and we are going to make a lot of maps, hopefully nice looking maps, informative maps, and we will have a lot of fun during this month doing that. Yeah, so the main goal of the course, which hopefully explains also the structure we have planned for the course, is here. So we want to make good maps, and during this course we will learn what makes a map good. So when we say a good map, what do we actually mean? And the other thing is the technical side of it. So knowing what a good map is one thing. Knowing how to make that, how to implement those ideas in our maps is another thing. So we are trying to cover these two aspects during this course. So we have, I will go through the structure of the course in more detail soon, but we have the lectures, we have the discussion sessions in which we try to understand what a good map is, and then we have those more technical side where we have the tutorials and the help sessions where we learn how to implement those ideas. So some of you might be familiar with this format of course if you have previously taken GeoPython and AutoGIS, and I know some of you have. So we follow the same format in this course, so it's an open course for anyone from anywhere in the world who wants to learn about cartography. So this website is open to everyone, but of course those who are officially registered to the course will get more support from us, and you get the credits for the course. So these are the learning goals for the course. So by the end of this course, hopefully we'll have a better understanding of the cartographic principles, theories, and then we will learn how to apply those to Yo maps in order to make better maps. So the course has a lot of interactive content. Some of the pages have interactive contents, and we have put this kind of box, because not every dynamic content loads properly on this website, because it's a static website. So in those cases you just need to use Binder, but you will see this kind of box where it tells you that okay, you need to use another environment to use the fully. So during this course we cover a range of topics. So today we are going to do a little bit of introduction. We know that many of you, I guess all of you, have studied some cartography, so you have either taken cartography courses or you have had GIS courses in which of course you have created maps. So we all have some knowledge of cartography. So today there will be probably a bit of repetition, some of the things you already know, but the idea is that okay, we do a bit of review and we start learning new things. So yeah, so we start making basic maps this week, and one of the themes we are highlighting a lot during this course, and especially today, is to see cartography as an art. So this is something we want to highlight during this course, and we will talk a little bit about it today. And next week we will have actually a guest lecturer. Not a guest actually, Tuuli Toivonen will be giving the next week's lecture. So she will talk about digital turn and geospatial data. So she will talk about cartography and big data, and also she will cover the topic of color theory and talking a bit more about colors and how to use them in your maps and make your maps more accessible from a color point of view. And and then we will have discussion about colors and visual hierarchy. It's also hosted by Tool next week. Then the third week we have a lecture, actually guest lecture coming from all the way from Salzburg. So Franz Benjamin Mojtek will be talking about cartographic storytelling and critical cartography. Again, this storytelling is one of the themes that we would like to highlight during this course. So it would be good if you don't miss that lecture. And then we will have more discussion. We are still deciding about topics of some of the discussions, but this will be updated during the course. And in the last lecture, we will talk about map media tools and some of the future directions. For example, we are all aware of AI and how it's changing things, so we will discuss those and see where cartography is heading with these new technologies emerging. So this is an overall overview of the course. So let's go. And at any point, if you want to ask anything, just raise your hand. So you find a lot of useful information on this general information. Of course, there's the structure of the course. So Monday mornings, like now, we will have the lectures. And because the course is intensive, everything is happening in 4 lectures, we have limited time to deliver all the information we want to you. That's why the lectures might not be super interactive, because there's a lot of information. But then again, we have these discussions in the afternoon where we will have the time to discuss things, so it's a bit more laid back. So in the afternoon from 1 to 3, we will continue in Exactum room D122, discussing some of the topics, and each week we will give you information, instruction about the topic of the next week, so you can come a bit prepared, knowing what we are going to discuss during the discussion session. So tomorrow, every Tuesday, we have the tutorials. So the idea is that, during lecture, during discussion, you have learned something. So, for example, next week you're learning about colors and color theory. And in the tutorial, we make a map and we implement those ideas. So the idea is that, you learn the theory, then in tutorial, we walk you through how it works. And we have, I've been asking around from the students, and we came up with the idea that, there are students who prefer to do things in a coding way, like using Python, which we specialize in this department mostly. So some students want to do the maps with Python. Some students prefer to use the software, QGIS in this case. So we decided to give you both options. So we will have 2 tutorials and also 2 help sessions. Help sessions will be on Thursday. So we basically create the same map, whatever that map is for the week. I will do the Python group, where I will create the map using Python, open source libraries. And then Tatu will be in charge of the QGIS sessions, the help sessions, and also the tutorial. So he will show you how to create almost the same map, but in QGIS. So it's up to you if you want to join either or both of them. But of course, there are 42 students right now registered to the course, and these are happening in the GIS classrooms downstairs. If everyone shows up, which may not be the case, not everyone would fit there. So that was another idea why we divided these 2 groups. So it doesn't matter which group you have registered to on SISU. You can choose, and you can change at any point. So so you can use either Python or QGIS, or even a combination of both. One week you may want to create your map with QGIS. You might have a reason for that. Some weeks you might want to use Python for that. And today, probably in the afternoon, we will discuss a bit more about, some of you were unsure, because I had this poll on Moodle last week. So we're going through your responses. Some of you are unsure which one is better for you. So in the afternoon, we will have a brief discussion, going through the pros and cons of each of the approaches. And hopefully after that, you will know how you want to continue. But both options are available to you. You can choose from. And then we have the help session. So people involved in this course, you already saw me and Tatu is sitting here. Tuli will be just giving one lecture, one discussion next week. But of course, she has been also involved in developing the ideas. Then tutorials are done by me and Tatu. As I said, I will be in charge mostly for the Python part and Tatu for the QGIS part. And then we have Pasi Okkonen, who will be helping us with the exercise sessions. So on Thursdays he will be there. Probably me and Tatu will show up at some point, depending on how many students are there and how much help Pasi needs. But he will be mostly in charge of exercise sessions. And in this general page, you will probably need to come back to this page a few times during this course because there's some useful information here. So there are a few links, the homepage of the course where we are already. And for those of you who are doing things the Python way, we will use a CSC notebook environment and Jupyter Lab. So those of you who decide to go with Python, we assume that you have already done some GIS with Python, probably have done the GeoPython AutoGIS courses, because we are not going through the details of things. So we will use the CSC notebook environment, and that's the join code for the workspace. Of course, you can create your own Python environment if you want. This is just easier, more readily available solution for you with all the libraries installed, the ones that we teach in this course. And then we have the GitHub repositories. This is where the course's website is hosted, and the tutorial materials are uploaded there weekly. So if you're doing things the Python way, then you have to pull the changes you have to clone the library and then pull the changes weekly to get the latest materials for the week. And our main way of communicating outside class will be through Discord, where me, Tatu, and Pasi are present to help you with your questions. If there are announcements, we either make it on Discord or we'll send you notification on Moodle. So you already noticed probably that we also have a Moodle space, which we will not really use. It's just a place to return your assignments and your final project work. So otherwise, not much will be happening on Moodle. Are there any questions? Is everything clear so far?
Short note that also on QGIS tutorials, I'll probably ask you to launch the notebooks, just because there's going to be some interactive materials that are nicer to do in Python. So.
Yeah. So you might need the notebook environment also in the QGIS, but it doesn't really mean that you need to be good at programming. So if you don't want to go the Python way, this doesn't mean you have to do Python. Just we might need the interactive space for certain things during the QGIS sessions. Yeah, and then some useful links, especially if you're doing the Python version of the course. So check out the materials from AutoGIS courses and GeoPython to refresh your memory on how GIS works in Python. So a little bit more information about the course environment. So we will be using QGIS if you're going the software way. And for those of you who use Python, we'll be working mostly in Jupyter Lab environment, which is hosted on CSC, and we will work a bit with Git and GitHub. In this course, the goal in each assignment is to produce a map. So regardless of how you make the map, whether you use coding, whether you use software, we do not ask you to submit the code. So we are not really using GitHub. You don't use GitHub to submit anything to us. You mainly use GitHub to deliver materials to you, but of course, as we have learned in previous courses, for those of you who have been on AutoGIS and GeoPython, version controlling is good if you're going the Python way. So then we have Discord and some links. You will need this link to the tutorial repository to clone it in the CSC notebook, so later there might be probably questions, but we can find it in course environment. And because a lot of this information is already covered in AutoGIS courses, like about Discord and GitHub, so we haven't repeated those on this course's webpage. You can I've just put the reference to the AutoGIS website, and also you can follow the link to learn about, I'm sure you're familiar with Discord and many of these tools already. If you're not, you can check out those material, so there's a lot of detail on AutoGIS courses page. So about the grading, so the course is made of, well, you get 40% from weekly assignments, so every week there will be an assignment. You create a map. So each assignment is like 10% of the grade. And then 60% comes from your final project. I will briefly talk about the final project today already, so you can start thinking about it, but there will be more details coming during the course. But yeah, so I've gotten many questions from the students whether it is obligatory to attend the class, because many students have summer jobs, could not make it like on every meeting. So it is not obligatory to attend the class. Personally, of course, we have a lot of like interactive things happening here. We have discussions. So if you're not here, you will definitely miss out a lot. So we encourage you to attend. And as a bit of extra encouragement to attend the classes, you get 20% extra your grade if you're actively, up to 20% extra if you're actively present. So during the course, including today, like on tutorials, on discussions and lectures, we will ask you to write your names to show if you're present, but this doesn't mean that those who are not coming, they will be punished or lose grade. It's just those who are present and active in discussions and everything, they will be rewarded. So up to 20% extra, and then the final grading is like this one. Same as most courses. So on the courses, like in this course information section, there's a lot of information about like week by week learning goals that I won't go through now in much detail, but you can check them out. In each week we cover a number of topics, and there's some very detailed objectives that we want to meet every week. So make sure not to miss the lectures and discussions. As I said, for those of you who are using Python, we have the CSC notebook environment ready. We will go through more details of it tomorrow in the tutorial. But in case you want to create your own Python environment, there are instructions again on AutoGIS course page. And on the courses website, on the courses site repository, there is an environment file, this YML file, and also a requirement.txt. So if you want to create your own environment, Python environment, you can just use the environment file or the requirement file. But you don't have to. So we have the CSC environment, which is nice and easy to use. A little bit about use of AI in this course. We are open to use of AI in this course, so if it helps you correct your code or learn something, this is great. If it supports your learning, it's okay to use it. The only thing that is not allowed in this course is like producing the output of your work. So you cannot ask ChatGPT or whatever large language model to create a map for you. Probably it will create a very bad-looking map for you anyway, but so the output, whether it's the text that you have in your report or assignment or the map, cannot be produced by AI. Otherwise, if you get support in some way, if it helps you learn, then we are fine with that. Resources, there are a number of books. But we will have, on most weeks for the discussions, we will have some article to read that we will publish. We will send to you in the week before the actual meeting, the week before. So in addition to that, there are some books which we have used, articles we have used for making the website and the course materials. So if you want to learn more, you can check those out. But for these courses specifically, you do not need to read those books. These are just extra reading. All you need to complete this course and meet the learning outcomes of this course is published on this website and covered during the lectures and discussions. But there are some good books and other resources for learning if you're interested. So this is the structure of our website following the course information section. For each week, we will publish new material. So now you see the material for week 1. So we have the lecture material, so it will be We have the lecture material, then we have the practical things like the tutorials and exercise information appearing here. And so for example, now this part is rather empty, but following the lecture, I will put the lecture slides and the recording here every week. Yeah. I guess that was the introduction. Do you have any questions, or Tato, do you have anything to add?
Maybe should be second.
Yeah. Okay, then if not, we're gonna start the actual lecture for today. So I put up my slides. Hope the recording goes well. There are often surprises. It might have stopped in the middle or something, but hopefully it goes well. So those who are not here today can still see what has happened during the lecture. Yeah, so we will record the lectures and tutorials. So the discussions we do not record. So it's not necessary, and also we will all be more comfortable discussing things if we are not on the camera. So yeah, so let's get it started. Today we are going to talk about cartography and introduction. So we'll cover some of the theory, some of the principles of cartography. As I said, there will be probably a bit of repetition. Some of the things are already familiar to you, but after this, hopefully there will be more new materials. We will learn a lot together. So yeah, so in this morning we are going to talk about cartography, a brief review. So we will look at a historical overview of cartography, because there is a long history of cartography. So in order to know where we are standing, it would be useful to know where we are actually coming from a cartographic point of view. So we will cover very briefly a short history of cartography, a bit of review on what we already know. Then we will we will cover some of the design-related topics. So we will talk about cartography as an art and what we mean by that, something I've said already a couple of times today. So we'll talk about that. We will briefly talk about map projections, which are quite important when it comes to making maps. And then we will briefly discuss layout design and a bit about colors. So I will just briefly talk about colors, because we are going to use it in the map this week. But there's more on color coming, like totally within the next week, talk about color theory, and we will cover the topic more depth next week. So since there are many of us here in this cartography course, I guess I don't need to go too far explaining why visualization is important. Probably you all have a good idea why it is important. There's a famous saying that a picture is worth 1,000 words, and that has been proven to us, I guess, many times in our life doing different things. You might need to read a very long text describing a certain phenomenon, but then it might take long and you may not have a full understanding of it, but once you look at a picture, you might quickly get a good idea of the patterns and turns in your data. So picture is a very effective way of communicating information. This is particularly important for geographic data, because in geography, a lot of things are about spatial relations, distances, densities, trends, and how this change, how this vary throughout the space. So this is something that it can become sometimes difficult without visualization, like describing how the density of a certain phenomenon varies throughout the space. So that's why visualization is important to most kinds of data, but particularly to geographic data that we work with. And maps are important important for communication and decision support tools. So during this course, we will see that for geographic data, the main way of visualizing is creating maps, and that's what we are going to do mostly during this course. But one of the themes we are covering during this course is that there is more. There are different ways of visualizing geospatial data. As I said, map is the main way, but there are other ways, non-cartographic ways of visualizing the data. So this is also something we will be talking and thinking about during this course. But yeah, maps are important for communication and decision support tools. So if you're not already convinced why visualization is important, I'll show you this classic example, which you probably have seen.
Sorry, just quickly, has everyone written down their name here?
So probably have seen this in other courses. So it's a classic example showing why visualization is very often important. So here you can see 4 data sets that they're not the same, but if you just look at them quantitatively by numbers, they look almost identical. So here we have some descriptive statistics. You can see that the data sets have almost the same average value. They have more or less similar variance, and correlation is almost the same. If you do a linear regression, you get this almost the same line. So if you just purely look at the numbers and those calculations you have done, you might think that, okay, these data sets are quite similar. But when you actually visualize them, you can see that they are quite different. So this is an example of why and how visualization can be very important. It cannot, maybe it's not the whole thing, but you need both very often. Look at your numbers, do your calculations, but at the same time you need the visualization. So cartography is the art, science, and technology of making maps. So this is pretty much the structure we are following in this course. We are trying to highlight the fact that there is science behind it. There are a lot of theories, concepts, some of which we will cover during this course. There are a lot of books on cartography. So there's a lot of science behind that. There is a technological side to it. So we will learn, like, for example, how to create maps in Python or how to do it in QGIS. So there is technology involved, and you need to learn how to use. And over time, probably you will learn most of the science if you study. And if you create a lot of maps, you probably become eventually very good at making maps in Python, QGIS, or any other platform you're using. But one thing that does not really have an end is that artistic part of cartography. So you can never say I've mastered the art of cartography, because there's always more to learn. There's always more. You can always do better. So that's one thing that makes cartography interesting. So you can always make new maps that look different. There are many data sets that have been visualized many times in many different ways, but you can always create a new visualization. It's the same as every art. So I don't think we will ever run out of music to make or painting to draw. So I guess the same thing applies to cartography. You can always, with that artistic view, you can always make new maps, even if the data has been mapped or visualized many times before. So we will cover the scientific part, the technological part, and also the art. Neither of us, me and Tatu, are artists, but together we try to make good maps here. So historically, maps have been used for various purposes. So cartography has changed a lot over the centuries. So as I said, it's a very old field. So it has changed a lot. So one of the main motivations of creating maps in the first place was probably for navigation purposes. So the maps were made so our ancestors could find places, so that they wouldn't get lost if they're traveling on land or on the sea. So one of the main motivations was probably for navigation. But another important motivation behind cartography and how it was born was probably for storage of geospatial information. So people went somewhere, they discovered something, and they wanted to keep that information so they would remember, okay, there is this certain resource in this particular area, or I can go from point A to point B using this certain route. So they wanted to store this geographic information, and maps were the way to go. So they draw things on the map so that they can store geographic information. This is one of the things that has changed significantly over time. Now we do not really think of maps as storage of our geographic information, but rather we have the geographic information in somewhere in our database, in some storage device, and then we create maps as an output. So that is one of the things that has changed significantly over the history of cartography. Maps have been used as tools for planning. They have been used. Another main motivation of cartography and map making during history was probably for territorial claims. So they wanted to know, okay, this tribe, this country, they wanted to know where their territory ends, where the new country, the territory of other tribe or country begins. So that was also one of the main motivations of how cartography became a thing historically. And yeah, and art, it has been present as a form of art during history as well. So maps are very powerful. They're powerful in shaping our perception of the space and place, especially if you think about space in 2 dimensions. Very often, if you're thinking how to go from point A to point B somewhere, for example, in Helsinki, and if especially you're not super familiar with the area, the image we get how to go from point A to point B might be a 2D image we have on the map in our mind. So very often you might remember a map from Google Map or whatever map you use more often to remember, okay, how do I go from here to there? So they really shape our perception and understanding of space to some level. And over the history, they have influenced the routes of exploration. So depending on what maps we had from which areas, it has really affected which areas we explored or not. And it has been used historically a lot to assert political control. So depending on geographical information you have from different places, you could have used it to assert your political control. So they have been significant historically in many different ways. So one way of looking at evolution of cartography, and a simplified way of it is a bit like this. So maps were originally as a way of storing geospatial data. But over time, they changed to more of something we use for communicating geospatial data. And this communication can be in different ways. Sometimes you communicate some geospatial information with someone else, like you make a map to make a presentation to someone, or you have done some analysis, you want to share your results with your colleagues or whatever audience you have, but also they are important in communicating the data with yourself. As I showed in one of my examples already, like data can be a bit inaccessible if you just look at numbers. So you have to have a way of communicating with data because we humans are not like, if you just look at an Excel sheet, a CSV file, it's very hard to understand the data. We have to find a way of communicating with the data, and cartography has been one way, a powerful way of doing that. So nowadays I would say cartography is more for communication of geospatial data, either with other people or with ourselves. So if you look a bit more closely at the evolution of cartography, we can see that there have been different phases, and all of them are still present, but maybe they have... Presentation has been always there. You make a map and the presentation is a component there. But as we have had more and more interactive tools, there has been more emphasis on also synthesizing data. So imagine, now with interactive tools, if you're using QGIS or Python or ArcGIS or whatever software, you have this way of interacting with your map, and that allows you to explore the data, do analysis, synthesize data. If you have different kinds of data, you can combine them, create new data sets in new formats. So cartography has evolved to be just from something that is mostly for presentation to something that also allows you to manipulate the data, do analysis, and explore the data, of course, with the help of interactive tools. So a bit of historical overview of cartography. So there are, depending on what book you read, what resource you refer to, there are different ways of classifying the history of cartography. This is just one way of getting some idea how things have changed over history. So we have the earliest stage of mapping, when we have the ancestral mapping, so to say. So it's prehistoric. It's from cave paintings to clay tablets, earliest spatial representation of places. So this is very old. We even have the birth of the world map. There are some old examples of maps. Like this is a recreation of an old map. They had some idea of how the world works. Of course, a bit different than how we see the world nowadays with our knowledge. But yeah, so the maps go very far back. They were in the early days. They were used for expansion of roads for controlling the empires. For example, the Roman itineraries are quite detailed. There are an early example of how maps were used in politics, for example. Then we come a bit forward, like in medieval worldview, of course, things have changed a bit. We have the religious influence. We have maps portraying the religious territories in different areas. Also during the same era, navigation, like in sailing to other places in the world, became a bigger thing. So we have a lot of maps and charts for navigation and sailing. So that was another change during this medieval time. And then we have the Islamic golden age. Like there are great examples of maps showing very detailed information about different places. So cartography, in a way, really flourished during this period. And then we have the Renaissance mapping. So this was the age of discovery. So there were a lot of voyages to other ends of the world. So they needed better and better maps, more accurate maps. And at the same time, we had the printing press emerging, so we could actually print the maps. So if we made a map, we could have copies of it, not just having one map made by one person. So that was a big change. And then we had, during the same era, we had some influential cartographers like Mercator, or Abraham Ortelius. So some famous cartographers were making great maps already during that era. Then we come a bit more forward. We have the Enlightenment era, and the cartography changed drastically there. So it's the period where the rationalism and empiricism became a thing. So there was a quest for accuracy and details in the map. So whoever was ordering the map, for example, the king of somewhere wanted a map of their new territory somewhere, or place they had colonized. So they were requesting more accurate maps. But also there was changes in science. So also science was going for more, for more accurate. Science was getting accurate in many ways, so cartography was just one form. We wanted more accurate maps. And then this is also the era where the surveying started to become a thing, so we could have calculated things a bit more accurately. For example, we could have done triangulation, we could have done surveying in a certain way to measure things, and this also led to better maps. Yeah, it was the same era where we had also thematic maps emerging, becoming more prominent. Then we have modern cartography. You're more familiar with this one. There has been a lot of technological advances in recent decades that make digital mapping. Digital mapping is one of the most obvious examples that has changed a lot of things. We have GIS, Geographic Information System, that has emerged in the last few decades, and it has become prominent. So this computerized framework of the spatial data has really changed how we create maps. And then we have satellite imagery, GPS, and different kinds of different sources of geospatial data, which has again contributed to the kind of maps we can make that revolutionized the accuracy and accessibility of modern mapping. And now there are still big changes happening. Cartography today, there are certain trends. For example, open source and crowdsourcing is a thing. This is still kind of young, so platforms such as OpenStreetMap have been democratizing map making. So map making used to be something that some elites have access to. If you're a very certain number of cartographers with access to information could have access to map. But now it has been a bit democratized, and that's a huge change for cartography. And then maps and power is another relevant topic nowadays. There is a lot of talks about privacy, surveillance, geopolitical representation of places. So these are some of the relevant topics in cartography. And there are trends, things that probably we'll see in the near future, but we already see trends emerging. For example, new technologies are appearing or have appeared and are constantly evolving, like augmented reality is still quite young, but probably in a few decades we are going to see more of it, better examples of it. And thinking about how cartography will change in light of these technologies is something we should think about. Or AI or autonomous vehicles, how would we change maps? What kind of maps will we need or can we make in this new era? So these are some of the topics that we should think about. In our last lecture on the last week, we will cover some of these things. We will have a discussion thinking where cartography is heading so that we can follow more. Maybe we are the leaders to lead the cartography to the right way. But yeah, we will talk about these things during this course a bit more. So what is the first step of making a map? It depends on how you see it, but any ideas?
Choose the thing you want to make the map about.
Yeah, that's true. But I mean more on a technical way. You have this data coming from the world, you want to bring it on a piece of paper. So one of the first things you do, what is that on a technical level? This would have been probably every cartographer's dream. If the Earth was flat, our job would have been a lot easier. But I know there are still flat Earths somewhere. Hopefully we don't have them in our class. But yeah, so very old days we didn't even know about the curvature of the Earth, so things were just easy. Of course, denial is a bliss. So we didn't know about the curvature of the Earth. We just mapped things like that, and it was easy. But if the Earth was like flat like that, which is not, things would have been easy. But now we know that Earth is not flat and it has a very complicated shape. And for bringing, and maps are 2D. Nowadays we have other ways of visualizing maps, but it's still, even if it's on the screen, it's mainly two-dimensional. So you have to have a way of, mathematically speaking, you have to have a way of bringing your 3D world into two-dimension. And that has been one of the oldest challenges of cartography, at least since we learned about the fact that Earth is not flat. So this has been one of our oldest challenges. So Earth's shape is complex, so it's not a globe, it's not even an ellipsoid, a perfect ellipsoid. So the geoid, the actual shape of the Earth, is quite complex. So that's one of the challenges, and also it's of course in 3D, so bringing it to a two-dimensional needs a bit of calculations. So there have been many attempts over the last few centuries to create this way of bringing the 3D world into 2D, which is called projection. But that's why there are literally thousands of projections to choose from. This is an example Robinson projection, which is very commonly used for like world maps. So there are many ways there are many projections available, many of which are just there because of historical reasons, because many researchers, many scientists wanted to just try a new way of doing projection a bit better. And also for geographical reasons, there are projections we will talk about that work better in certain areas. That's another reason why we have a lot of projection systems to choose from. So there's a bit of usually confusion about terms, so what we mean by coordinate system and projection system. So When we talk about coordinate system, we can simplify it into two types. So we have geographic coordinate system, in which we do not project our world to 2D. So the coordinates are in 3D. So we have a reference. So there's a reference for the shape of the Earth. It's called datum. And there are different ways of how mathematically this is defined. There are a few common datums like WGS84 that represents the complex shape of Earth in a way that is suitable enough for our purpose. And then there is a way that we have like, these are by definition. So we have defined a coordinate system, so we start counting from certain place in certain degrees or whatever units we use. So that's what a coordinate system is. And then we have projected coordinate system that we refer to as map projection. So it is a coordinate system, but it has also been brought to 2 dimensions. So it is called projection. So do not confuse those. So geographic coordinate system is not projected by definition, and then we have this projected coordinate system. But you are bringing your data from 3D world to 2D. So like most things in science, if you're doing that conversion, there is something you lose. You cannot do a perfect conversion. So you always lose something, no matter how good the projection is. These are some of the things you usually lose. So you lose a bit of accuracy on the area representation, like how angles are, directions are, distances are. And then you probably have some map considerations. So you have a purpose for your map. You know where your map is from. What are you thinking? Are you using the map for navigation, or are you just using population density in Helsinki? So depending on what you are mapping for, that's a factor to consider. Also familiarity. Like if you're making a map of Finland, for most of us who work here, you probably have a good understanding of which coordinate systems work well enough here. But if they ask you to make a map of, I don't know, the other end of the world, it becomes a challenge. Like I was working in Singapore for a while, and like creating maps for me was like difficult, like especially when related to projection. Like where do I start from? What are the practices here and what works best? So it is a challenge for many of us working with GIS cartography if we are not familiar with the place. And then there are different options to choose from that we will briefly talk about. But there are many types of projections that we have talked about already briefly. But this text is very small, but so there are different projections that try to preserve some of these things that we usually lose. Depending on our need, we will choose from one of them. So we have like projections that are conformal and they preserve the angle. So they lose other things, but they preserve the angle. They have equal area projections that preserve the area if that is something that is important for you in your map and you don't want to change that. But then they mess with like angles. Then we have equidistant projections that preserve distances in your map. If it is important for you to create a map where people can reliably calculate distances between places, then you probably want to go for a projection system that is working that way. And then there are these compromise projections that you try to like find a balance between what you lose so you find a good enough map again for your purpose. There are different projection systems to choose from. And there is a lot of books. You can get a book full of like mathematics behind how these projections work. But I'm focusing this course. But generally, what happens? We use the surface, and then we project our world into that surface. So cylinders, cones are examples of how this is usually done. Each of them have certain characteristics. So we have the cylindrical projections that wrap the world into a cylinder, and there are also these pseudo-cylindrical projections, so they're a bit like changed. So this is an example of them. So if you just open a cylinder, it just becomes a flat paper like that. But it of course creates a lot of distortion at the poles, so that's why there are these other projections like Robinson, where the ends are a bit like bent inward, so it reduces the distortion. So there are a lot of projections that you can choose from. There's a lot of math behind that. If you're interested, you can read books. But yeah, so what we need to know, the more you know, the better, the easier it is to work with projections. But projections are very important, as I said, but it is somewhat understated in the world of cartography, so we do not talk about it as much as we should. And I think there are a number of reasons for that. One of the reasons I think is that they're just scary. There's a lot of mathematics behind them, and many people who make maps, they're not comfortable with that technical side of things. So they may not even not be like, one of the things about cartography or GIS, which can be considered good or bad, is that maps have become accessible to many people. So before you had to study a lot of like geography, GIS, cartography to make a map. Now, someone might be an interdisciplinary researcher who has learned a bit of GIS and might produce a map without knowing what is a projection system. So that's maybe one of the reasons why they're not taken seriously enough. Another reason why we don't think about them so much is that we have worked with projections for centuries, and there are so many established habits and even rules. But many of the things have been standardized. So like in Finland, for example, I have an next slide talking more specifically about what we use in Finland. So there are like rules, like there are standards which works best here. So we don't think about it, we just adopt what is advised. And very often there are habits that are not even good. So we just follow what is popular. So that is the image of, well, we know geography, so I guess you know that is not a good map. But very often people have this distorted idea of how the world looks like because of bad projections. So yeah, this is a Mercator projection that was not super popular until a couple of decades ago because it has a lot of problems, especially how it distorts. At least it's not good for world representation. It distorts areas significantly toward the pole. So the higher the latitude, the more distortion you have in areas. So if you can just look, most people probably think Greenland is probably the biggest Africa, which is not the case. It's just the Mercator messing with the presentation. So very often we just create a world map using Mercator because that's what we have seen on Google Maps, on OpenStreetMap. So just following what is a standard or a habit is not necessarily always a good idea. So we should think. So this is Mercator projection, which is very commonly used. As I say, it's become popular again with the web maps. Particularly, I guess Google Maps has started using that. Web Mercator, which is a version of Mercator. So it's a cylindrical projection. It was originally made by the famous Mercator for navigational purposes. So it's a conformal projection that preserves angles and directions, but not areas. So it is not well suited for general world maps. It distorts sizes in higher latitudes. It works well for web maps, especially this Web Mercator, which is an implementation of it for web, because it just works well with their algorithms. It just works well with navigation, and that's why they've used it. But it doesn't mean that it's a good map if you're making a world map to put on your wall. This is not good. It might be good enough for Google Maps, but not for free. So whatever is common doesn't necessarily mean it's good. So you should be a bit critical of what projection system you use in your work. Just briefly about what we use in Finland. Again, in Finland, like other places, we have standards, we have rules that we follow. So very often use the data, so the coordinate system we use is an adopted version of a European system, and the ETRS 89, which we call in Finland, and then we have the projected coordinate system, this TM35 thing that we get our data sets, like especially if you get a statistical data, like population data. They usually come in this coordinate system, which is a transverse Mercator projection. But you might be already wondering that, okay, Finland is very high in latitude, and I just said that Mercator is not good for high latitude. So how come you're using this projection? Finland. Any idea? Exactly. Yeah, so it's a transverse Mercator. So the cylinder is like put like this way, so it works well for the polar areas, enough the polar areas, and it doesn't work so well for equator, for example. It works well enough for Finland, so this is something we use quite a lot. This is standard for Finland. Yeah, so it's hard to say what to use, what projection to use, what coordinate system to use, for what, but to just give you some rough idea, I know there's a lot of text you can read later, but to just give you some idea when we should use a geographical coordinate system, because we do not always have to use projected system. It's again like a bad habit that we always are used to using this projected system. But yeah, so you may want to use geographic coordinate system if you want to, if you're working in a global context. So we have rather good projection systems for smaller areas, for example, in Finland. But globally, it's a bit tricky. So if you're working on a global scale, you may want to consider to go without projection. Data collection and storage. If you're just collecting data on a world level and you're storing it without making map, because things get tricky when we want to create a map in 2 dimensions. So if you're just collecting data just to store it for future, for some purpose, then you don't need to use projection, because with projection you're distorting your data. When you cause that distortion, it's harder, impossible to undo it. So if you have a data set that is only in projected system, you lose something and you cannot undo it. So if you're just storing your data, it's usually better to store it on a geographic coordinate system. And we have more geodetic accuracy, so people working with geodesy, they don't like projection so much unless they need it for some reason. So you have more accuracy. So these are some of the reasons why you may not need a projected system. But very often, if you're just making a small map, not a small map, a map of a smaller area, like if you're making a population density map of Finland or Helsinki, then there are these local projection systems that work well, and they make your life easier, and they look nicer and easier to work with. There are certain engineering projects which might need this projection, and mathematical and statistical maps, especially from smaller areas, it works quite well. And if you don't need a cartographic output, projection can help you with map making. So this is just some rough guideline where to use what, but there's more to it, so you need to always evaluate the situation depending on your needs. So now a bit of activity, so I'm not the only person talking all the time. So we have a little flinger here. So we have studied cartography before. Just whatever you know, what is a good map? Anything you have learned over these years of studying geography, whatever field you're coming from. Just show your ideas. Let's find out what makes a map good. Okay, I start to go briefly through this, but you can still add things. You already have a lot of great ideas, so I'm afraid many of my slides coming will be repeating what you already know. But that's great that you know so much already. Yeah, there's a lot of information here. For example, like data is of course the main thing, which is saying like rubbish in, rubbish out. So if you make your map, your analysis or your map based on that quality data, of course, what you get as output is not be good by miracle. So that's a key thing. Then you have mentioned north arrows. I like the smiley face after. You have mentioned map elements, and I like the smiley face after north arrow. Yeah, we always have to have that. Then, yeah, your map has to be clear. You should have a clear purpose. You should know your audience. You should not overcrowd your map. Yeah, some elements you need always. Like the scale bar very often is needed, but not always. Knowing the audience, as we mentioned a few times, is important. Title is very often needed. And yeah, and being honest with your map, because it's easy to lie with maps. Book about it, classic book about it, how to lie with maps. So yeah, honesty matters. So let's get back to these slides, and many of the things you nicely mentioned here will show up again there, but we can go over them quickly. Okay, so a bit of review of what we already knew. So, cartographic grammar. There are a lot of rules and guidelines that you have learned about, and now in the Flinga you just added many of those. So you should have a title, you should have a north arrow or many map elements. You should be careful with colors, like make them accessible. So these are rules and guidelines that we have been taught during our courses in different sources. So these cartographic rules and guidelines are very often referred to as cartographic grammar. So, like I mentioned a couple of times already, there are these software like QGIS, ArcGIS, and many more that make creating maps rather easy. Not making a good map is not easy, but technically speaking, making the map a little bit easier. The learning curve is a bit different nowadays. So, but there's one problem with those, or one limitation. That is that, okay, there's no guarantee that the map you make is good or effective. There are this grammar, there is this cartographic grammar that is part of cartography, but is not implemented in this software packages. So if you use QGIS as your map, it doesn't automatically make the map good for you, and that's one of the reasons maybe why we see a lot of bad map examples. Another thing is map elements. Map elements are very important, like a map is made of elements. So choosing what to include and where to put them is one of the main things we will learn during this course, or we will get to practice during this course. So one of the things we have been told is that, well, we will see a long list of elements on the next slide. We have always seen those, and we have been taught that, okay, you always have to have those elements. So we are a bit like addicted to always putting a north arrow in our map, or always a legend. Very often they're needed, they're useful elements, but not every map you may not need those. So just automatically putting them in every map without thinking whether it's needed or not is another pitfall in cartography. So you should know the map's purpose, audience, and the specific information you want to convey using your map. And then you choose, okay, which elements should I include and which one I should highlight or emphasize a bit more. And of course, some elements are always needed in your map. For example, if someone just shows you on that map and asks you to interpret that, it's hard to say anything other than it's some area and probably there's a body of water there. There's no legend, there's no title, there's no information. So without elements, the map is essentially useless. So these are the list of elements that you have seen many times during your studies. Well, some of the main elements. So it's important to think of the map itself as an element in your map. because that gives you a bit of flexibility and open mind when it comes to choosing the layout of your map. When you think of it as an element, it's like you're a bit more flexible to move it around. So that's a good view of the map. And then we have other elements that are commonly used. So very often, not always, but very often you need a title for your map. A legend is almost always needed. Scale bar, sometimes needed. You might need the north arrow, which will give a bit of orientation to your map viewer. And then metadata is, of course, needed very often, especially for legal reasons. If you're just using data from a third party and you're visualizing it, you get credit for that. So these are some of the things we very often need in our maps. But if you check out cartography books, you see lists like this, or even longer, some of the elements you might need in your maps, and some of them are very good and relevant, some of them are a bit like, we don't use them as much, but depending on the map you're making, you might need some of these things. I won't go through these, but just reminding you that there is a long list of things you can include in your map, but you should not always include all of them. Depending on your map and what it is made for, who it is made for, you might choose to make some of them. For example, if you make a map of Helsinki, people who live in Helsinki, local people who know the shape of the area and everything, you may not necessarily need to include a north arrow if it is already familiar. It's stating the obvious. But on the other hand, if you're making a map of Helsinki and you want to present it to, I don't know, international audience where they may not know very well where Helsinki is or how it is oriented, then it might be a good addition. So it really depends on what the map is made for or who it is made for. So there are these primary elements that we very often need, at least some of them, and secondary elements that really depend. And during your courses, what you have learned before, you have learned about map symbols that we use to represent items. We have different geometries that we represent in our maps. We have points, we have lines, we have areas and surfaces. And even in more modern maps, we might have complex 3D shapes. We have different kinds of symbols. We have symbols that are pictures. So if you are visualizing people's homes, imagine if you have survey data or you have home location of individuals for some reason you want to map. So this is a picture that tells you if it is at home. It's very self-explanatory. And we have associative symbols that this doesn't necessarily tell you much, but to most of us this is a reminder of a health care station, hospital or something. It doesn't really tell you much, but over the years we have just learned to associate this symbol with a hospital or healthcare center. And then we have these abstract symbols, like a pin that doesn't really mean anything, it's just abstract, but we are so used to seeing them on the map that we can use it to represent different kinds of places. One thing that is hugely important when it comes to symbols is a bit of like the, of course now we have this world that is very interconnected, so this is becoming less and less relevant, but still when using symbols you should take into account the context and the culture. I guess there isn't anyone in the world who wouldn't understand this is probably a health center or some hospital, even if it's a cross. But there might be a culture where this may not say much. If you put a cross, it may not represent a hospital, for example. Or if you're mapping worship places, probably it's, you should visualize it differently in different contexts. So when choosing symbols, you should think a bit about the context and the cultural background of people to whom you're making the map for. So one concept that we have probably seen a lot in geology and cartography is the concept of visual variables. Because sometimes we just have symbols, but very often we have like variations. So you have different kinds of symbols. Or there is an attribute attached to the symbol. So for example, you want to make a map of hospitals, but you want to also visualize how many beds or how big the hospital is. Then you need to add a bit of visual variable to also visualize that. So for example, you can have, nothing is necessarily a good idea, but you can add a color. So the darker the color of the symbol, the bigger the hospital. Or you might make the size a bit proportional to the size of the hospital. So usually very often to convey this kind of information in our maps, we use the concept of visual variable, which emerged like 60 years ago. So it's a famous concept. So there are different visual variables that we use in our maps. So depending on what you want to show, you may want to finish, but there is English here. So there is shape of the symbols or the elements that you can change to convey different information. For example, if you have home and hospital and both are on your map, so you just use different symbol, different shape. Or sizes, like I said, the size of your symbol can be proportional, can be related to attributes you have linked to that data, linked to that element. And then you have color hue, color brightness, texture, orientation, all these things you can change in your map elements, in your symbols, for example, to convey different kind of information. More modern maps, you might even use color saturation, there might be 3D elements depending on what you're doing. Transparency was a thing that was difficult to work with when we were working with paper maps, but now QGIS or other software is just a slight bar, you can adjust the transparency according to your needs. There are a lot of things that we can change within our platforms, either Python or some software we're using. That's the idea of visual variables. So this is a map of Helsinki tram lines from 2017. So let's just spend a couple of minutes on this. What visual variables we see here? I'm going to start. We have different colors here. The color here is showing different tram lines. What else do you see here? Yeah, and the stops, they have different stops. It's just different shapes, so it shows you that this stop is different than the line.
Other types of transportation hubs like metro stations and bus station and railway station and the ports.
Yeah, exactly. So there are different shapes.
You have the number for the tram lines.
Yeah. We also have texture there, so they added, the cartographer has added a bit of texture to show that that's a train line. So we can argue whether this is a good map or not, but it's a good example of how you can use visual variables in your map. So what we talked about, like some of the elements, some of the things we covered, for example, visual variables are universal, regardless of whether the map is going to be printed or is going to be a web map. We use some form of visual variable. But nowadays we have web maps, for example, a screenshot of OpenStreetMap here, and there are certain elements that you cannot find in a classic cartographic book from 1950s. Because we didn't have web maps built back then. But there are new elements that are relevant to building platforms, for example, web maps. So very often in web maps, you need some kind of tool to make some selection. So for example, in Google Map or even OpenStreetMap, you can click, select an item on the map, and then there is usually a pop-up window with information about the place. Such tools or navigation, like being able to zoom in, zoom out, and pan around the map. So these are some of the elements that are relevant on these interactive maps. And there are extra considerations when it comes to, we are going to work with interactive web maps later during this course. And there are some extra considerations to make with these maps. For example, you have a user interface here, like in a map. it's different. The interaction is different. Here you have a user interface. You might want to also think about how intuitive it is, how user-friendly the map is. And if you're using commands, buttons, menus, they're not really part of your map, but they affect how usable your map is. So it's fair to think of them as like map elements. Kind of. And of course, you need to know what the map is for. Like, are you making a web map for urban planners in the city of Helsinki, or are you going to make a web map for, I don't know, public audience where they want to go and find a restaurant and read those reviews about it? Depending on what the map is made for, again, you have to make some considerations. It's a bit different for interactive web maps. So types of map, generally speaking, maps can be divided into two groups that we have seen before during your studies. So we have thematic maps that show data relating to a particular theme or topic. Then we have these topographic maps containing a diverse set of data on different themes. So in this course, we are going to work with thematic maps. And these are the examples of thematic maps I'm sure you have studied about before. So we have different kinds of thematic maps, some of which we will work and practice with during this course. So what we learn, as I already showed you this on the course's webpage, so what we are going to learn in the rest of my slides today and during the coming lectures is to see what a good map is about and how we can actually create it. So many of you already mentioned many of the things I have on this slide. So if you want to make a map, there are a few things you should take into consideration. But many of you mentioned resources are important, like what kind of data you have, or what kind of computer, or what kind of device you have for visualization. That's important. The purpose of the map affects what kind of map you should make. The culture and context, which I mentioned already, are important. Many choices you make regarding your map. And the users, media of presentation, is the map going to be printed, or is it going to be a web map or on a website? And of course, what are you mapping? So is it like are you mapping the altitude of places, or is it a map of, I don't know, places in Helsinki, urban areas? So this affects some of your choices. So this is a quote I found from a book which I've been reading recently, The Cartographer by Paul Shepard. I like this line: "The world is canvas, and we are the artists who bring it to life through our maps." So this is something that we are going to play with this idea during our course. And it's like we have Python, we have QGIS, which is very technical. But at the same time, let's have this in our mind that we are trying to create a piece of art through our maps. So let's see. See it as an art, and let's try to create as nice looking maps as possible. Of course, making your map look nice doesn't mean that you have to mess with the information or anything. You want to keep it accurate and correct and everything. But at the same time, let's make it look nice. This is an AI generated image. So as I said, cartography combines aesthetic expression with scientific technique and technological considerations to create maps. The cartographer's palette is rich. We have lines, points, different kinds of tools and elements to work with. So you can think of it, if you're an artist, and this is your palette. This is what you're going to work with to create beautiful maps. So you have a good inventory when it comes to map making. It's important to think of maps as not just tools, but it's a piece of art, as I said. So let's make them look nice. Nowadays we have digital tools that allow you to combine these traditional designs that we have learned from cartography courses with these nice graphic elements. So you can really go far. You can do a lot to make your map beautiful. So even making your map, if you make your map in QGIS or Python, it doesn't necessarily even end there. You can just take it to another graphic software and make it even better. But you have to remain loyal to the data and not that's accurate, of course. So during this course, we will explore what map design and how to do things a bit in a nicer way. So layout design. So this is one of the most important things that I hope we get to practice during this course, and that's layout. Like when you look at the map, I think there are a few things that really or notice right away. One of them is layout. Where you put things, it really affects how the map is seen, so whether it's nice or not. So if you put an ugly big title somewhere, it might really affect how your map looks like. So you should be a bit considerate of layout and where to put things. So this is one approach you can use that works for many cartographers to create maps. So first, you create a list. Take a piece of paper when you're making a map. Make a list of the elements you want to include. So ask yourself, do I need a map legend? Well, map legend you should need, but do I need a map north arrow here? Or do I need a title in this map? Make a list of the elements that you find relevant to your map. And then decide, like just draw before you anything with things in QGIS or whatever platform you're using, just draw a sketch of what your map will look like. So decide where to put things, what is the layout of your map. And try to get input from others. So we are very often biased to what we create ourselves. We might make a map that might look amazing to us, but if you show it to someone else, it might look ugly or unreadable. So depending on what you're using the map for, try to get feedback from people and improve your map according to the feedback you get. And layout also affects but you should know what you want to be emphasized in your map. Sometimes a map is very self-explanatory. Even the legend is not super important, it's just for extra information. You may not want to have a huge legend. But sometimes the legend has a lot of information that is like core, very fundamental to understanding the map. Then you might want to put it in a place, make it a bit bigger to bring a bit of attention to it. So think that if you have a huge north arrow, probably the north arrow is not the center of attention. You don't want it to be like the main thing in your map. So having a huge north arrow somewhere in your map will draw a lot of attention that you may not want. So think about where you put things and how big you make them. So by accident you don't emphasize on something that is not so important. So these are like one of the things that affects the look of your map, and we are going to practice this a bit in our tutorial this week, is the placement of titles. So there are many options where you can put your titles, and you have probably seen many examples of such maps. So this is one of the things that affects the look of your map significantly. And also you can combine if you have a title, you can also add other elements there. For example, the legend can go in the same box or area. These are some of the classic choices, and it really affects the looks of your map. So these are just some options, but the point is that there are many possibilities, so you should go through them when you are making your map. So with title, the title should be, first of all, think if you need a title. If you're putting your map, for example, in a journal paper or in a thesis, and in your thesis you have a caption for the image explaining what this map is about. Do you still need a big title for your map? Maybe not, maybe yes. So these are the things. Where are you putting the map? Will you need the title or not? And the title should be informative. It's very common. Sometimes you are asked to do it this way by your company or the organization you're working with, but it's usually a bad choice to put the name of your company. Like if you're coming from University of Helsinki and you put University of Helsinki and make a map of something relevant in Helsinki, that's not usually a good idea. But you see examples of that. So be mindful with the title you use. It should be informative and short. And also you can do extra things with your title. This is just an example. You're making a map of birds that are going extinct to make a bit of more impression. You can play with the words, you can play with the font, you can do effects like this, which are very simple to do, especially if you're doing it in software. And it might affect how people see your map, what kind of impression you make. Yeah, so today, during the lectures, we are going to talk more about fonts and colors. Get back to this. We've already covered the topic we talked about graphic variables, visual variables, so I won't go through that. But one thing is that there are a number of number of classes you can just perceive without getting confused. So if you have, 30 colors in your map that don't make sense, it becomes super confusing and unusable for the user. So this is just some classic guideline on how many classes of things are easily perceived by the user. So if you're using different orientation of dots or dashes, like for example, like up to 2 classes can be easily seen by the people. Or if you're using different textures, how it works. So this is not an absolute thing that you have to like follow this. Just be mindful if you're using colors. If it is a hierarchical color, for example, it's not a problem. But if you're using very distinct color, if you're having 20 different colors, it's just confusing for the reader. So there's a limit how much you can include, how many visual variables you can include. So we won't talk about colors much for a topic for next week, just briefly so that we know what we're doing for this week's exercise and tutorial. So we talked about like title and layout, how important it is in the first impression the map makes. Color is another thing. It's one of the things that we like pick up very quickly when we look at an image. So colors are very important. Good choice of color, proper choice of color can enhance map readability and viewer comprehension. So one way of using colors, and this is something we will get back to later. So sometimes very often we make maps, we just choose colors that we are used to or we like. But if you really want to be like systematic, like a bit like correct with use of colors, you should learn a bit about colors, and these are not usually necessarily coming from cartography books. They're books about color theory, from graphic design, from different fields. But they really teach you about colors, how these colors are seen, what kind of meaning they convey. So if you really want to get good with colors, you should get a book about colors and read about it. And there are also rules in cartography. You can also, of course, get inspiration from. So if you see a painting and you love the colors, and you think it's suitable for your map, you can get inspiration from a piece of art. Or if you see a map you really like, you can use the colors from that map. So a combination of theory, rules, and inspiration can help you make good choice of colors. And it's not only the color you use, but also the combination of colors together affects how your map looks like. And this is something that went through very quickly now. We'll get back to this next week. Many of you already mentioned color blindness, and it's a serious thing. Even some people here may have difficulty to distinguish colors here. So it's something to think about, but we'll talk about this more next week. Remember, when you're making your maps this week, just too much is too much. You do not want to overuse colors, like too much colors. There's a limit. So try to find the balance in use of colors and different elements in the map. Use moderation and be strategic with what colors you use and how many of them. Yeah, so these are some of the references for what we talked about today. Sorry I talked quickly, but there was a lot to cover this first lecture. That was it. So if you have any questions, unless we have a couple of minutes for questions, if not, we'll just continue in the afternoon without discussion. Exactly. So see you in there.